everyone. Welcome to today's session on decision tree, a fundamental topic in data analytics. I am Priyadashini, Assistant Professor, Department of Computer Science and Engineering at SNS College of Technology. In this lecture, we will see how decision tree work, their structure, algorithm, and how they are used for classification and regression track. Here we will see about the introduction to decision tree. Decision tree are one of the most powerful and intuitive supervised learning model. They can be used for both classification and regression problems. Essentially, a decision tree breaks complex decisions into sequential of simple if-then rules. This structure makes them very easy to interpret and visualize, which is why then they often prefer in business and healthcare applications. By the end of the session, you will understand how decision tree make prediction and why they are so effective. Next, we will see about the structure of decision tree. Let's look at the basic structure of a decision tree. At top, we have the root node, which represents the entire data set and the first split. Then we have decision nodes, which are point where further split occur based on future value. The leaf node or terminal node represents the final output, that is the predicted class or value. And finally, branches shows the flow of decision from root down to the leaves. This hierarchy allows the model to simulate human-like decision making. Next, we will see about the key decision tree algorithm. There are three main decision algorithms you should know: ID3, C45 and CART. The ID3 algorithm uses entropy and information gain. It's mainly designed for categorical future. With successor, C45 can handle continuous attributes, manage missing values and even generate rules. Then we have CART, which is classification and regression tree, which uses Gini impurity to decide split and support both classification and regression. Each of these algorithms shares the same goal to find the most informative way to split the data set. Next, we will see about the splitting criteria, Gini impurity versus entropy. When building a decision tree, we need to decide where to split the tree. Two main metrics used for this is entropy and Gini impurity. Entropy measures the randomness in data. Higher entropy means more disorder. Information gains tells us how much entropy decreases after a split. Gini impurity, on the other hand, measures the probability of misclassification. Both aims to make the resulting child node as pure as possible, meaning they should contain mostly data from one class. Next, we will see about the mitigating overfit through pruning. One of the biggest challenge with the decision tree is overfitting. When the model become too complex and start learning noise instead of meaningful pattern. To prevent this, we use pruning technique. There are two types: pre-pruning or early stopping, where we stop growing the tree beyond a certain depth, or maximizing number of simple samples per node, and post-pruning, where we build the full tree first, then remove branches and don't add value. We also use cross-validation to find the optimal pruning level, ensuring the model generalization well to new data. Next is visualization of decision tree. One of the biggest advantage of decision tree is that they can be easily visualized as flowchart. Each node represents a future and each branch represents a possible outcome. This visualization helps in three ways. First, it makes the model interpretable, so even non-technical stakeholders can understand it. Second, it clearly explains the decision process. And third, it helps us see the decision boundaries, how the model is dividing the future space. Next, we have a case study. Now let's look at a practical case study, predicting diabetic using decision tree. We use features such as fast blood sugar level, BMI and blood pressure. The tree might first ask, is fasting blood sugar greater than 126 mg per dl? If yes, it moves one way. If no, another way. Each split brings us closer to a final decision at a leaf node. Diabetic or non-diabetic, each leaf node has a purity score, showing how confident the model is in its prediction. This example shows how decision tree simplifies the simplifies even complex or medical diagnosis. Next, we will see about interpreting output and summary. To interpret a decision tree predicting, we simply follow the decision path from root to leaf node. The leaf node gives us the predicted output and its purity indicates how confident the model is. In summary, decision trees are intuitive and powerful. They strike a balance between simplicity and predictive performance. However, I'll always remember pruning is crucial to avoid overfitting and maintain generalization. Next, we will see about the key strength of decision tree. Let's have a quick recap about the key strength. First, interpretability. Decision trees are transparent, making it easy to trace decision. Second, versatility. They can handle both classification and regression tasks. And third, robustness. With pruning, they perform reliably even in real-world noisy data set. This makes them one of the most practical tools for data scientists. To conclude, decision tree form the foundation of many advanced algorithms like random forest and gradient boosting. This visual and intuitive structure helps us understand complex data relationships. They are effective for both categorical and numerical data across domains like medicine, finance, and marketing. The key takeaway is that decision trees do not just predict outcomes, they explain them. That was what makes them an essential tool in data analytics and machine learning. I hope you understand this concept. Thank